Big data analytics.
The solution is big data analytics. The decision making is based on what you know, which in turn is based on data analytics. It provides a comprehensive view of the overall picture, which is a result of analyzing data from various sources. It provides streamlined decision making from top to bottom. Big data analytics helps in analyzing unstructured data. It helps in faster decision making, thus improving the competitive advantage and saving time and energy.
Let's look at a case study. In this case, Google's self-driving car. A Google car is equipped with numerous sensors which collect data on the real-time surroundings. According to an estimate, each car produces around 1 gigabyte of sensor data per second. That would add up to 2 petabytes of data per year per car, assuming that the average car owner drives 600 hours in a year. Of course, not all of this data is important and will have to be stored. Currently, the servers needed to process this data are in the car's trunk and require their own large cooling system. The data produced by the car can be classified in 3 ways. One is technical data, or inside out, learning about avoiding obstacles such as cones or cyclists. It's the data that comes from the car's sensors and is analyzed by the car's machine learning algorithms. 2 is community data, or outside in, crowdsourced data about traffic and driving conditions from ways like platforms. And 3, personal data, riders' personal preferences regarding driving locations, indoor temperature, in-car entertainment, etc., all serving to improve the user experience. Google's autonomous cars collect all 3 kinds of data, but most of the processing power is used in consolidating technical and community data. Most of the data is coming in real time, and the cars need to make split-second decisions based on it. That is a great application for big data processing. Big data analytics pipelines. Let's look at the layers. We'll start with the data ingestion layer. This layer is the first step for the data coming from variable sources to start its journey. Data here is prioritized and categorized, which makes data flow smoothly in further layers. The data collector layer. In this layer, more focus is on the transportation of data from the ingestion layer to the rest of the data pipeline. It is this layer where components are decoupled so that analytic capabilities may begin. Then we have the data processing layer. In this primary layer, the focus is to specialize the data pipeline processing system. Here, we route the data to a different destination, classify the data flow, and it's the first point where the analytics may take place. Next is the data storage layer. Finding a storage solution is very much important when the size of your data becomes very large. This layer focuses on where to store such a large data set efficiently. The data query layer. This is the layer where active analytical processing takes place. Here, the primary focus is to gather the data value so that it is made more helpful for the next layer. And last is the data visualization layer. The visualization or presentation tier is probably the most prestigious tier, where the data pipeline users may feel the value of the data. We need something that will grab people's attention and make your findings well understood.